Hi learners, do you know that a study says that adding one robot to a geographic area reduces employment in that area by 6 workers? The present automotive industry employs around 38% of existing industrial robots. Also, do you know that an automation will displace between 400 to 800 million jobs by 2030, requiring as many as 375 million people to switch jobs categories entirely? A study by McKinsey Global Institute says that by 2030, robots will eliminate as much as 30% of world's human labor. According to a 2016 study by the World Economic Forum, technically highly equipped countries such as Switzerland, Netherlands, Singapore, Qatar, or the US are considered to be particularly well prepared for the fourth industrial revolution. Low labor cost countries such as China, India, and Bangladesh are still benefiting from their surplus of low skilled workers, while Western companies are still outsourcing their production to these countries. If, however, these companies decide to produce in their countries of origin in the future using production robots and only a few workers, the surplus of low skilled workers might turn into a curse for these developing countries. Another problem for developing countries such as India, Thailand, or China is the lack of social security systems. Possible mass unemployment could lead to human catastrophes and a wave of migration. Accordingly, the same rule applies to developing countries as to developed countries. Jobs with low or medium qualification requirement will be eliminated in the end. About 47% of total US employment is at risk, whereas 70% of total employment in Thailand or India is at risk. In many sectors, the implementation of autonomous system requires too much of an investment at present compared to the existing labor cost. At the same time, production robots are becoming less expensive year by year. Replacing human manual labor with robots makes economic sense in low labor cost countries, when the cost of human labor becomes 15% higher than the cost of robotic labor. This will happen in countries such as Mexico by 2025. According to a study by the Boston Consulting Group, Chinese companies are already starting to build factories where robots will replace 90% of human workers. The developing countries in Central and Southern America will also not profit from the trend of the fourth industrial revolution. It is to be feared that these countries, like the North African countries and Indonesia, are not equipped to face automation and digitalization due to the lack of education of much of the population, lack of investment in a digital infrastructure, and lack of legal framework. Further complicating the matter is the rising birth rate in the North African and Arabic countries, which will lead to high rates of youth unemployment. For every older employee in Uganda or Nigeria, 7 younger employees will enter the badly structured national labor market. In these countries, only 40% of younger generation is in employment, and most of these jobs are low-paid jobs without social security in the third sector. On the other hand, the winners of the digital revolution are likely to be highly developed Asian countries with good education systems, such as Singapore, Hong Kong, Taiwan, and South Korea. These countries, together with the Scandinavian countries, have been undertaking research and working to find digital solutions for complex issues for a long time. The digital interconnection of people in these countries is also very far advanced. The share of the population at risk of unemployment in these countries is only about 6%. Western developed countries will profit from the relocation of the company's production sectors when robotic production becomes cheaper than human production in low labor cost countries. This will create new jobs in the Western countries and destroy many routine jobs in the low labor cost countries. Another positive trend that can be seen for India and China, which are both considered very suitable candidates for participation in the digital revolution. Due to the most of the population in this country have a good command on English and IT skills. Not only the salaries and wages are lower in India, but also the number of better qualified professionals are there in India. It is the reason why 25,000 IT jobs are likely to be outsourced to India from the UK alone. Even though more than 80% of the robots sold each year are deployed in Japan, South Korea, US and Germany and enhance the productivity in the production sector, the new business model in the service sector are the digital future. With the economic growth in this service sector, the US will be particularly resistant to the future economic crisis. Let me explain to you the lights out production concept and the smart factory. This light out production concept is where manufacturing activities and material flows are handled entirely automatically. It is becoming an increasingly common attribute of modern manufacturing. The future new wave of automation will be driven by the same things that first brought robotics and automation into the workplace, which is to free human workers from dirty, dull, or dangerous jobs, to improve quality by eliminating errors and reducing variability, and to cut manufacturing cost by replacing increasingly expensive people with ever cheaper machines. The target in this regard is the so-called smart factory. A smart factory is characterized by the intelligent machine taking an active part in the production process. In this context, the machines exchange information and control themselves in real time, which causes the production to run fully automatically. Most companies are still a long way from reaching this target, but there are many attempts in individual production areas to work towards achieving a smart factory situation. The robo prices are falling day by day. Robo prices have fallen in comparison with labor cost. As robo production has increased, costs have come down. Over the past 30 years, the average robo price has fallen by half in real terms, and even further relative to labor cost. As demand from emerging countries encourages the production of robots to shift to low-cost regions, they are likely to become still more cheaper. The robots are also getting smarter day by day, where early robots blindly follow the same path and later iterations used lasers or vision systems to detect the orientation of parts and materials, but the latest generation of robots can integrate information from multiple sensors and adapt their movements in real time. This allows them, for example, to use force feedback to mimic the skill of a craftsman in grinding, deburring, or polishing applications. They can also make use of most powerful computer technology and big data style analysis. For instance, they can use spectral analysis to check the quality of a weld as it is being made, dramatically reducing the amount of post-manufacture inspection which is required. The robots also started taking on new roles. As the cost and complexity of automating tasks with robots goes down, it is likely that the kinds of companies already using robots will use even more of them. In the next 5 to 10 years, however, we expect a more fundamental change in the kinds of tasks for which robots become both technically and economically viable. Here are some of examples. The advances in artificial intelligence and sensor technologies will allow robots to cope with a far greater degree of task-to-task variability. The ability to adapt their actions in response to changes in their environment will create opportunities for automation in areas such as the processing of agricultural products, where there is a significant part-to-part variability. In Japan, trials have already demonstrated that robots can cut the time required to harvest strawberries by up to 40% using a stereoscopic imaging system to identify the location of fruit and evaluate its ripeness. These same capabilities will also drive quality improvements in all sectors. Robots will be able to compensate for potential quality issues during manufacturing. Examples here include altering the force used to assemble two parts based on the dimensional differences between them, or selecting and combining different sized components to achieve the right final dimensions. While today's general-purpose robots can control their movement to within zero point 0.10 millimeters, some current configuration of robots have repeatable accuracy of 0.02 millimeters. Further generations are likely to offer even higher level of precision. Such capabilities will allow them to participate in increasingly delicate tasks such as threading needles or assembling highly sophisticated electronic devices. Robots are also becoming better coordinated with the availability of controllers that can simultaneously drive dozens of axes, allowing multiple robots to work together on the same task. Finally, advanced sensor technologies and advanced computer that analyzes the data from those sensors will allow robots to take on tasks like cutting gemstones that previously required highly skilled craftspeople. The same technologies may even permit activities that cannot be done today. For example, adjusting the thickness or composition of coatings in real time as they are applied to compensate for deviations in the underlying material, or painting electronic circuits on the surface of structures. Companies will also have far more freedom to decide which tasks to automate with robots and which to conduct manually. Advanced safety systems means robots can take up new positions next to their human colleagues. If sensors indicate the risk of collision with an operator, the robot will automatically slow down or alter its path to avoid it. This technology permits the usage of robo for individual tasks on otherwise manual assembly lines, and the removal of safety fences and interlocks mean lower cost, a boon for smaller companies. The ability to put robots and people side by side and to reallocate tasks between them also helps productivity, since it allows companies to rebalance production lines as demand fluctuates. Robots that can operate safely in proximity to people will also pave the way for applications away from the tightly controlled environment of the factory floor. Internet retailers and logistics companies are already adopting forms of robotic automation in their warehouses. Imagine the productivity benefits available to a parcel courier, though if an onboard robo can pre-sort packages in the delivery vehicle between drops. Finally, I end this video by saying, despite these fears and concerns, every technological shift has ended up creating more jobs than were destroyed. During the Industrial Revolution, more and more tasks in the weaving process were automated, prompting workers to focus on the things machines could not do, such as operating a machine and then tending multiple machines to keep them running smoothly. This caused output to grow explosively. In America during the 19th century, the amount of coarse cloth a single weaver could produce in an hour increased by a factor of 50, and the amount of labor required per yard of cloth fell by 98%. This made cloth cheaper and increased demand for it, which in turn created more jobs for weavers. Their numbers quadruplated between 1830 and 1900. In other words, technology gradually changed the nature of the weaver's job and the skills required to do it rather than replacing it altogether. A period of high unemployment in which tens of millions of people are incapable of getting a job because they simply don't have the necessary skills will be our reality if we don't adequately prepare